Alright, no one touch the table. Yeah, you can see it here.
I feel like more are joining in with that now. I think it's growing.
Yes. Yes, it feels like there's the tissue is...
1, 2, 3. I don't know if this is so strong it's pulling this in.
Yeah.
I think that's just this here. But you can see this one beating first or faster. Whoop.
My name is Wataru Hijikata from Tokyo Institute of Technology, and I'm studying on the research about the artificial heart or wireless power transfer for the patient with the implantable medical devices or some wearable devices such as power assist suits. And also I'm studying on the implantable energy harvesting systems for the implantable medical devices. In the research about the self-powered pacemaker, we use a skeletal muscle and we apply some stimulation to the muscle, and the muscle consumes the chemical energy from the blood glucose and they make a contraction.
So measuring a cell on a soft surface is a bit difficult because you're measuring the surface as well as the cell, and currently the field is developing new ways to analyze it to separate both from each other.
I'm Thomas Iskach. I'm a senior lecturer in bioengineering at Queen Mary University of London.
So Hacking Hearts is an experimental project designed to interrogate and reimagine contemporary scientific research. And the research that you will be interrogating is centred on heart disease, energy harvesting and cellular sensing. So we have visiting scientists from Tokyo Institute of Technology and Queen Mary University who are going to present their research to you, to be hacked.
I recognized artists could understand the essence of our research. And now they are trying to express the science by their own way.
Okay, so now we have got the second is we've got the materials. You know already about the body. You know you want to build or you want to make, you want to demonstrate, you want to form some sort of interface. And I'm going to take you briefly through the materials bar. And so there are stretchy things, there's bendy things, there are things with structure, there are things that you can form, like wires for example. There's a big kind of table with lots of larger scale, mostly stretchy or springy materials. We've got all sorts of tubing, silicons, foamy sheets.
To tell the truth, I thought that explanation about the detail of the research is not necessary, but realistic materials or some tangible devices are more important to communicate with the art and science.
Yeah, these have 3 of our bite marks into the little Play-Doh or plasticine, which is the, I guess, virus that's powering this this very random connection.
We wanted to make with this device a connection between the strength of the bloodstream that comes from this part and with the strength of the bloodstream, try to find a mechanism that could give energy to this device.
At the moment, we have a lot of different ideas and mediums, and today we want to take a few each and experiment and see what works and what doesn't work, and kind of go from there.
medical progress for saving people is definitely one big social value, right? And that's very important. Nobody disagrees. But where is
it's just like
other
just
value?
you decided
Can somebody sort of develop the idea?
I have to like
we are looking at our bodies more
in
in terms of like it can be fixed.
Depends of where you want to go.
Because the question is, are we prolonging life? Like, is this the main goal? Or are we thinking of a quality life or a quantity life? And again, for who? Who is the one who has access to these technologies? It's a huge issue.
And that's the exercise that we're engaged with here is the reinterpretation. So bringing it into your domain. What can the arts and design disciplines do with these subjects and these thinking? How do you want to work with this material?
I don't know how you're feeling about it, but it's kind of the language is getting closer in terms of what words people are using, but also kind of the understanding from the students towards the science through the discussions that I or the scientists have with them. And our understanding, I guess, for the artistic approaches to the project as well, like by interacting with them and also participating at least a little bit.
We're going to stop and then with a small explanation for the audience, ask them to do their own version, and they will be given a piece of this each as they walk in. We've structured this based on statistics from the British Heart Foundation as well, so it's a kind of using the crowd to represent data as well. So the amount of these, which are the diseased hearts, is based on the percentage of diseased hearts today in the UK, people living with heart disease.
And we're also interested in seeing if the crowd syncs up, just like Thomas's research with the beating hearts, with beating cells.
Looking forward to see how other projects kind of continue to, the different ideas that the students are having combine into actual projects and how they turn out then. So I think the symposium should be really exciting tomorrow. So I'm looking forward to that.
We have 3 performances, and they will come one after the other. So I'll introduce the 3 groups at the beginning. The first one up is Organic Mechanic. Then the next group is Beyond Human. And we finish with the Cell Collective. So please, Organic Mechanic, stage is yours.
Hello, I'm an example of a new hybrid post-gender species called plantains. And plantains are the result of a paradigm shift in humanity, in which the humans are not the rulers of the world anymore and are not living on Earth, but rather embedded in the world.
When there is a cut or injury on the skin, a liquid is used to isolate the bacteria in the perimeters of the wound. The layers of the skin grow back, joining and pushing upwards, much like how mountains are formed. So in this way, human and plants are becoming together. Thank you.
What are your impressions? What are you taking away?
So I mean, I have to say it was like all very, very interesting kind of concepts that came out of it. And I mean, I didn't have much kind of a clear anticipation what the outcome would be. It was interesting that it all went down into this performative kind of output, and that there was like kind of a variety of different concepts, from the ethics to the more kind of representing the actual how the cells behave in a collective and so on. So yeah, it was interesting.
Oh, well, first, I would like to express many thanks for such impressive performances. At the first day, we gave a lot of data and principle, or sometimes technologies, to the students. Maybe it was too much, but they understand, and they could understand the essence of the science. And then they drag one or few words, few keywords, and hack, and they convert into their performance, maybe in the different dimension, and expand it. It's like, this is the conversion from data to the emotion. Right.